Section 1.3, linear functions. We have 5 objectives in this section. First is to identify linear functions, to find the intercepts and slopes of graphs of linear functions, to graph linear functions, to find the rate of change, and then lastly, to find marginal revenue and marginal profit from linear revenue and linear profit functions. All right, a linear function is one that can take this form here, f of x equals ax plus b, where both a and b are constants. So one example of a linear function might be this, f of x equals 2x plus 7. All right, in this example, let's determine if these given functions or these given equations could represent a linear function. A linear function must take this form, where a and b are constants. So if we can make the given equation look like this equation, then we'll know that's a linear function. All right, looking at a first, a at a first glance doesn't appear to be in that exact same form. 0 equals 3x minus y plus 5. However, if we add y to both sides of this function, excuse me, then we have y equals 3x plus 5, and it does look like an linear function. It does now match the form. Look at b over here. This one's a bit odd. It doesn't look like a linear function either, does it? In fact, there's no term with an x in it. There's no x there at all, okay? But what if I add something that doesn't change the value? What if I write this like this? Y equals 0 times x plus 9. All I've done is I've added 0x to both sides, or just added it to the right side because it's just 0, right? It doesn't change the value of anything. Now, it does look like the form that I have up there. I do have an x term, right? I do have an x term. It just, in the process of simplifying, 0 times x is just 0. It's nothing. So y equal 9 is also a linear function. What about option C over here? Now that definitely does not look like the form that I need, y equal ax plus b. It's xy equals 5. Well, let's see, what happens if I divide both sides by x? If I divide both sides by x, then I have y equals 5 over x. Well, is there anything that I can do to this new function to make it look like the form that I need for linear functions? The problem that I have there is that x is in the denominator, and I don't have an x in the denominator in the form that I need for linear functions. I mean, there's nothing I could do. The only thing I can do to get x out of that denominator is to multiply both sides by x, and then I get right back where I started, xy equals 5, right? So I would have to say then that C here is not a linear function, because I cannot make it look like it needs to look. All right, let's move on to finding the intercepts of linear functions. Think about the graph of a linear function. If I were to graph a linear function, it might look something like this, right? There's an x-axis, there's a y-axis, and then this, I'll make him green. This green line is our linear function, okay? The y-intercept of this linear function, we'll call him f of x, is right here, okay? And what is the x-coordinate of that point? Well, if we're on the y-axis, the x-coordinate has to be 0, right? I don't know what the y-coordinate is. Maybe it's -1, right? But the x-coordinate of that intercept is 0. So that happens with no matter what line I draw here, wherever it intercepts that y-axis, it's going to have an x-coordinate of 0. All the points on that y-axis have an x-coordinate of 0. So because of this, then if we want to find that y-intercept, we simply let x equal 0 in the equation, and we solve for y. All right. So there's an example here on the y-intercept of the graph of 4x minus 8y equals 16. Well, if we let x equal 0 and substitute that into our equation, we'll have 4 times 0 minus 8y equals 16. Of course, 4 times 0 is just 0. That just goes away, right? Then if we divide both sides by -8, we're left with y equals, and 16 divided by -8 is -2. So we can now say that the y-intercept for this equation is at the point that has the coordinates 0, -2. Excuse me. To find the x-intercepts of the graph, we're going to let y equal 0. Because look, where the graph intercepts the x-axis right there, the x-coordinate is, I don't know what, some value, maybe we'll just say it's 1, but the y-coordinate is going to be 0. All right, every point on the x-axis is going to have a y-coordinate of 0. All right, so because of that fact, then if we want to find the x-intercept, we have to let y equal 0 and solve for x. All right, so we will let y equal 0 and substitute that into our equation. So then we'll have 4x minus 8 times 0 equal to 16. Of course, 8 times 0 is just 0. So we have 4x equal to 16. And then when we divide both sides by 4, we see that x is equal to 16 divided by 4, or 4. So our x-intercept occurs at the point with the coordinates 4, 0. All right, let's look at an example, an application involving loan balance. So a business property is purchased with a promise to pay off a $60,000 loan plus interest of $16,500. And this will be done by making 60 monthly payments of $1,275 each. The amount of money, we're going to call that Y, remaining to be paid on the total loan amount. The total loan amount, of course, is the amount of money borrowed plus the interest. So that's $76,500. It's going to be reduced by $1,275 each month. All right. Therefore, we can write an equation or a function to tell us the amount of money remaining to be paid every month. And that function looks like this. Y, the amount remaining on the loan, is equal to 76,500, the initial amount, minus 1275x, where x is the number of payments that have been made. Okay, let's see if we can find the x and y intercepts of this function and interpret what they mean in context of the problem. All right, let's see. We'll start with the x-intercept. To find the x-intercept, we let y equal 0. So we'll say 0 equals 76,500 minus 1275x. And we'll solve for x. All right, I think I'll just add 1275x to both sides. So then I'll have 12 1275x being equal to 76,500. And we'll divide both sides by 1275 and we'll have our value for x. All right, and 76,000 divided by 1275 is 60. All right, now let's interpret what that x-intercept means, right? So that x-intercept is right when we start here, when right is at the very end when y is equal to 0. So this means that the loan is totally paid off. So if we were to interpret that, we would say the loan value is 0 after 60 payments have been made. All right, let's move on to the y-intercept. To find the y-intercept, we're going to let x equal 0. So then in our equation, we'll say y equals 76,500 minus 1275 times 0. All right, well, 1275 times 0 is 0. So we see that y is equal to 76,500. So our y-intercept is the point that has a coordinate x0, y 76,500. Our x-intercept, I didn't write that, but let's put that here, has an x-coordinate of 60 and a y-coordinate of 0. All right, so let's interpret what this means. When x is 0, so when x is 0, that's the number of payments that have been made. So we can say that when 0 payments have been made, the loan balance is 76,500. Okay. Another thing we could have said about this y-intercept is we could have said that it's the initial value of the function, right? It's the initial value or the starting value of the function. All right, so if we were to graph this linear function, how would we want to limit the x and the y-axis so that we have a nice viewing window of our function? All right, well, remember that x is the number of payments, right? And we can't have a negative number of payments. So I think that the payments, they go from 0 to, and it's all paid off after 60 payments, right? So I think that we want to limit x from 0 to 60. So we aren't going to have to worry about any negative values, and we don't need anything more than 60 because it's all paid off at that point. All right, so if our x-axis is here, we could label that 0 to 60. All right. Now, y, how do we want to limit y? Well, y was the loan balance. All right. Can it ever be negative? No. So our smallest value is probably 0. What was the entire amount? Well, it was 76,500 when no payments were made. So I think the smallest value we need on y is 0, and the largest, is 76,500. So let's see. This is our y-axis. This is down here. Y is up here. I think I'll make my high value an even number. I think I'll just make it a little bit bigger. I'll say it's going to be 80,000. All right. Now, I know my intercepts, so I can then use them to sketch the graph of this function. Let's see, if 80,000 is the top, 40,000 is halfway, 76,500. Let's see. That'd be 60, 70. It's about right there. That's about where we need to be. All right, and then of course, x is 60, y is 0. And there's a rough sketch of our function. All right, now let's move on to the concept of slope. What is a slope? Well, you know, if you're looking at a mountain or a hill or something, you might refer to the slope of that mountain. The slope would be this, how slanted that mountain is, right? It could be, it could have a very steep slope, or it could have a shallow slope. Mathematically, we define the slope when we compare the vertical change over the horizontal change when we move from one point to another point on that line. All right, that vertical change over horizontal change can also be referred to as the rise over the run, or maybe the change in y's. Delta is a Greek letter that we use to refer to the change in. So we might say it's the change in y's over the change in x's. Okay, so if we look at this linear graph here and 2 points that are indicated, you can see that the rise or the change in the vertical when we go from one point to another point is the difference in the y coordinates of those points, or y2 minus y1. And the horizontal change, or the run, then is the difference in the x coordinates of those 2 points, or x2 minus x1. All right? It's important to keep in mind that vertical lines and horizontal lines are a little bit different. The slope of a vertical line is always undefined because the difference in the x's is 0. Look, if I were to draw a vertical line on here, and I wanted to, you know, apply the slope formula from this point to this point, actually, let's put it right there where we would have a y1 and a y2, right? The difference in the y's is something, y2 minus y1, but we have no horizontal movement when we go from this first point to the second point. So there's no difference in the x coordinates. The x coordinates don't change at all. So that means that the x2 minus the x1 is simply 0. And can we ever divide by 0? No. Division by 0 is undefined. So we say the slope of a vertical line is undefined. All right, now for a horizontal line, let's put a horizontal line in, maybe right here. All right, if we were thinking about finding the slope from this first point to the second point, the coordinates of that first point would be x1, y2, or the first point, and then the second point would be x2, y1, right? So the difference in the x's is some value. The difference in the y's, though, is going to be 0, right? So to move from one point to the other, there is some difference in the x coordinates, but there is, oops, I did this wrong. Wrote them backwards. It's the y's that go on top, right? So the difference in the y's, of course, is 0. So this is 0 over something, whatever that x2 minus that x1 is. And 0 divided by anything is just going to be 0. So the slope of horizontal lines is always 0. The slope of vertical lines is undefined. All right, let's look at an example and see if we can calculate the slope of a line if we know 2 points that are on that line. All right, so here we have the points -7 and 3, call that x1 and y1, and 5, -1, call that x2 and y2, and these points are both on that line. To find the slope, we're going to use that formula, and we often refer to slope with the letter m. So we'll say slope equals the difference in our y's, or our y2 minus our y1, over the difference in our x's, our x2 minus x1. So it's going to be -1 minus 3 divided by 5 minus -7. Right? -1 minus 3 is -4. -5 minus -7 is -5 plus 7, or 12. So we have -4/12, which of course reduces, that will reduce down to -1/3. So we can now see that the slope of that line is -1/3. All right, so when we have a line that is sloping upward, like a plane taking off, it has a positive slope. When we have a line that is slanting downwards, like a plane landing, we say that that's a negative slope. Again, horizontal lines have a slope of 0 because there is no vertical change. So the numerator in the formula to calculate that slope is going to be 0, and 0 divided by anything is 0. The slope of the vertical line doesn't exist, or we say it's undefined. It's undefined because the denominator ends up being 0 in the slope formula, and we can't divide by 0. All right, so when we write the equation of the line in this format here, y equal mx plus b, where m is your slope, we refer to this as the slope-intercept form for the equation of a line. And we refer to it that way because m is the slope, and this value here for b is the y-intercept. If we were to graph that line. Okay, so let's look at these two examples here in A and B and determine what is the slope and what is the y-intercept. I don't need you right now. So is this first part A, is that equation written in the form that we needed it? Is it written in the y equals mx plus b? It looks like it is. Right? It looks like it is. We can see that the slope here, or m, is equal to 7. And we can see that the y-intercept, or the b here, is -12. Look at example B. Can we say that the slope is 2? No. Normally, when the equation is in the right format, the slope is the coefficient, or the number in front of the x, but this isn't in the right format yet. To have this in slope-intercept form, we have to solve for y. All right, we have to get y all by itself. So let's go ahead and do that. We'll subtract a 2x from both sides. So then we have -3y is equal to -2x plus 12. And then we'll just divide everything by -3. And we have, what we're left with is y equals -2 divided by -3 is just going to be +2/3. Negative divided by negative cancels that out. So we'll have 2/3 x. And then 12 divided by -3 is -4. So 2/3 x minus 4. Excuse me. Now we have it in the right format. We have it in our slope-intercept form. So we can see that the slope here is 2/3. And we can see that the y-intercept is -4. All right, let's look at another application here. Or actually the same one. Let's come back to our loan balance application. So what would be the slope and the y-intercept of the graph of this particular function? And then what do they represent in context of this application? Well, our equation, it's not quite the right form. We want it to have that x term first and then the y-intercept second. But addition and subtraction are commutative, so we can simply switch the order of those, and we can write this as y equals -1275x plus 76,500. Now I do have it in the right form, and I can now say that my slope is -1275, and my y-intercept is 76,500. All right, but what does it mean in context of the application here? Well, the slope is the rate of change in this function, or it's negative. So what we could say is that, every time we make a payment, every payment reduces the loan amount or the loan balance, I should say, by $1,275. All right. So for every X, payment X that increases, every time we increase X by 1, we reduce Y by $1,275. So what then does the y-intercept represent? Well, the y-intercept represents the initial loan balance, or we could say it's the loan balance when zero payments are made. Okay. Sometimes we refer to this y-intercept, we call it the y-intercept in context of a graph. But we can also think about this in terms of an application. This b is the initial value of the function. All right, linear functions always have a constant rate of change. It never changes. It's always going to be the coefficient of the x term when we've written the function in slope-intercept form. Okay, and the rate of change in the function is going to be the slope value. All right, so let's look at another example here. Here we have a graph of a model that is for data beginning in 1990, projected through the year 2050, and it's the percent of Hispanic or people with people with Hispanic origins in the U.S. population. All right. This model says h of x is equal to 0.224x plus 9.01. X is equal to the number of years after 1990. Okay, what is the slope of the graph of this function? Right. Well, since this function is in slope-intercept form, we know that the slope is equal to 0.224. What is the Hispanic population when this bottle begins, which is in the year 1990? Well, that's going to be the initial value on this particular model, right? Or we could say that 9.01 is the population in 1990. All right, one more example here. Let's look at marginal revenue and marginal profit. So there's a company that produces and sells a particular smartphone, and there's a revenue function given here. R of X equals 89.50 times X. And the revenue, of course, is in dollars. And there's also a cost function here. C of X equals 54.36X plus $6,790. And in these models, X is the number of smartphones that are produced and sold. So the first question here says, what is the marginal revenue for the smartphone and what does it mean? Let's see, marginal revenue. What is marginal revenue? Marginal revenue is simply the amount of revenue that is obtained from the sale of one more smartphone, right? So here we would say that the marginal revenue is the rate of change in the revenue function. Okay, so what is that rate of change? It's the slope, right? And in this revenue function, it's 89.50. Okay, so what does it mean? Again, 89.50 in revenue is obtained when one phone is sold. All right, the next part here is saying find the profit function. Well, what is profit? As a concept, profit is always going to be revenues less any costs incurred, right? So as a function, we could say P of X, profit for the number of smartphones produced and sold, that's X, is going to equal the revenue function, or R of X, minus C of X, the cost function. All right, well, let's plug in that revenue function and that cost function and simplify, then we'll have our profit function. All right, so P of X then is going to equal R of X, which is 89.50X, then minus the cost function. I want to make sure I put that in parentheses because there's more than one term, right? And the cost function is 54.36X plus $6,790. All right, let's simplify that a little bit. We should distribute this negative. So then our profit function will be 89.50X minus 54.36X, and then also minus 6,790. All right, we can keep simplifying here. We can keep simplifying because we have like terms that can be combined here. We'll do it up here where there's more room. So now our profit function is going to be 89.50X minus 54 36x, which is 3514x, and then minus the 6,790. All right, so there's our profit function. All right, now the last question says, what is the marginal profit for the smartphone and what does it mean? Okay, remember that marginal profit is the profit from selling one more smartphone, or we can also think about that as the rate of change in profit. Okay, well, if we look at our profit function that we just made, it is written in slope-intercept form, right? P of x equals mx plus b. So we can see here that our marginal profit is going to be 3514. Okay, what does that mean? That means that 3514 is obtained when, well, no, I better write this differently. There's $35.14 additional profit when each smartphone is sold. All right. That ends the lecture for section 1.3.